So the problem statement is saying there are piles of stones. Let's say there are 4 piles of stones and their value is 1, 4, 3 and 2. Now Alice and Bob will take turns and take first 3 stones. Uh, so Alice and Bob will take either first 3 stones, first 2 stones, or first stone. Okay, and Alice will start first. So and they will both play optimally. So they will try to maximize their score. So they will try to take as many stones as possible. And if they both end up with the same score, there could be a tie. So in the since the problem requires us to make certain moves, which is like take 1 stone, 2 stone, or first 3 stone from the leftover stone. So in such problems, we try to make every move possible. So we try to take 1 stone and see what outcome we can get, and we try to take 2 stone and see what outcome we get, and we try to see if we take first 3 stone what outcome we get, and we see if we are getting maximum stones in this we pick this, or we are getting maximum stones in this we pick this. So let's say there are 2 stones in the first pile, minus 4 stone in the next pile, and 10 stone in the last pile. So some might say like let's just take first stone because there is a negative number, and if we take that we will lose stones. But if we take all 3 stones, then in the end, the absolute value is always increasing, because like 10 plus 2 minus 4, which is 8. So at the end, we are getting an increment of 8 stones. And take this example 1, 2, 3, and minus 9. If Alice would be making the move first, so she would have to take all 3 stones. Why? Because let's say Alice take only 1 stone. Now Bob will take 3 stones. Now Alice have to take this negative number, due to which Alice would lose the game. And if she take like these 2 stones, Bob would always take this 1 stone. And because like both are playing optimally, so both will try to maximize his score. We Since question is saying we just have to return who will win the game, we don't have to return how much stone each can get, how maximum stone each can get. So instead of calculating the maximum stone for each player, let's say if we calculate Alice get 41, Bob get 50, I'm taking just an example. So if we take this, we have to maintain some for both of the player, because we cannot add the stones of Bob in the stones of Alice. Since it's not required for us to return a number of stone for both the players, so what we can do is since we just have to see that whose number of stone is greater. So let's say Alice has A number of stones and Bob has B number of stones. These are the maximum stone they both can get. And if Alice's stone is greater than Bob, this is what we have to return instead of number of stones. So what we can do is we can do A minus B is greater than 0. So now we just have to see if we remove Bob's stone from Alice's stone, if this thing is greater than 0, then Alice win, and if this thing is less than 0, then Bob wins. So now we just have to store this value and maintain this value instead of two different values. So now let's come to the implementation. So so let's take score is equal to solve, and this 0 is index, so we would be starting from 0th index, and we also give this stone value vector, and then 0 so this 0 so this So this last zero is actually the flag. So what we are using this flag for? So since since we are going to subtract a with b, we also need to understand whose turn it is, so that we can subtract. So if let's say flag f is equal to 0, we can say it is Alice's turn, so add the number of stones she would be taking. Let's say she is taking a stones, and if there is a flag is equal to 1, then it means it's Bob's turn and we would be subtracting the stones. That's why I'm taking a variable 0 as a flag. So now let's implement the solve function, and int I is index and its vector int and stone value. And see, I'm passing the vector by reference because it is a recursive function, and since value is not changing in the vector, we don't want the function to make copy of this vector again and again, so we are passing it as a reference. So it will help us in decreasing our type complexity and memory complexity. And we So now let's take n, which is the size of stone value vector, and now if chance is equal to 0, we know it's Alice's turn, and we iterate over from I to I plus 3 or n. So we know, like, if there's a stone values vector size is less than 3, so we cannot take the first 3 stone. We have only possibility of taking the first 2 stone or first 1 stones. And now we iterate over this, and on each pile we add it to the sum, because we are saying that Alice is taking this number of stone, and we see if it is the maximum if we take this number of stone or not. And for this we just and we now make another recursive call on uh, j plus 1, means the next pile, because Alice is now taken the stone she want in her turn, and now this would be Bob's turn. So here we are just saying, like, if let's say Alice took the first stone, will be the maximum number of stones she can get, or if she took the second stone, or if she took the third stone. So we are saying for all the stones, what is the maximum she could get. And let me initialize some variables I took. It should be 0, and Alice should be int min, because we are here taking the maximum stone Alice could take. And now else, if it is Bob's turn, we will do some same thing, and we say, like, we will take Bob as int max. I will explain this in a minute. And now let's iterate from I till minimum of 3 comma n. Sorry, it should be I plus 3 comma n, and j plus plus. Now sum plus equal to stone value j, and Bob should be minimum of Bob comma minus 1 into sum plus solve j plus 1 comma stone value comma 0. Now what I did here, see, here I am taking the negative. Why I am taking the negative? Because as I told you in the beginning, instead of seeing the maximum the Bob can get, we will see the subtraction, like if this is greater than 0 or if this is less than 0. Since Bob will only win if this is less than 0, so we will try to take as many stone for Bob as possible, but instead of in positive, we take it as negative. So we will subtract the Bob stone from the Alice stone, because if Bob gets more stone, then this would become negative, and if this will become negative, then Bob wins. And so this will help us only maintain one variable. So let's take the score, and let me say that score is the maximum the Alice could take, and here score would be the minimum the Bob, maximum negative the Bob could can make, and we will just return score. And here what I did is I said that if score is equal to 0, then it is a tie. Means like if Bob and Alice number of stone is equal, then the score should be 0, and if score is greater than 0, means Alice win. So this score is actually the A minus B. And so one thing we missed here is that it should be less than minimum of I plus 3 and the base value. So the base condition that n should be equal to I to return 0. Since if we reach to the end of vector, we return 0 number of stones any person can get. So now let's run the code. Since it's passing this initial test cases because they are very small, so here we are making lots of calls on this recursive function, and there are many calls which are actually overlapping. So to avoid those overlapping calls, we use this DP. So here I solve this problem using the recursive DP because iterative DP is hard to imagine. It's easy to imagine the recursive DP by memorizing it. So let's first take a DP array. So since the maximum can be 5 into 10 to the power 4, so I can take let's say 5005 and 2. So let me tell you the states of the DP. So this is the piles of stones. So there is the index of piles of stones because we are iterating over them here, and like we are iterating over it. So since this is changing, we are taking it and storing it, and this is the flag. So we should know if we come to some index earlier, whose chance it was that we got that score. So let's say on index 2, index 2, it was Alice turn, and here we get 41 stones. Okay, so if later on we come to this same index on some another call, because we are recursively making calls, um, um, so if we come to again, we will not calculate this again, we just return 41 which we have memorized it by storing. Now I'm using this mem set to fill it with -1, and now let pass it in the uh, recursive function. It is now we say if dp of I and chance is not -1, means we have not calculated this state. So we will so sorry, this means we have calculated the state because dp is not -1, because we have initialized it with -1. So if it is not -1, we will just say that we have already calculated it, and we are returning it from this array, and where we are storing it when we are calculating, here at the end before returning, we will store this score uh, in the dp. Now let's run this. uh, okay, so we have not passed it here. It should also be here. Let's run it. Let's submit it. Okay, so the solution is accepted, and if there is any doubt, you can ask me in the comment section, and I have also linked the solution in the description, and be sure to like and subscribe.